Okay, students, so here is the knowledge check, and let's just dive into it, all right? We need to find the value of x right here. So this pink angle, angle CAB, this is an inscribed angle, all right? And it's related to its intercepted arc, all right? So CB right here, this is an intercepted arc. All right. Now, as we're going to see, the fact is, I'll put I dot angle for inscribed angles are equal to half the intercepted arc. All right, so we need to find this arc measure right here and then just divide it by 2. All right, so how we're going to do that is AB right here. This is a diameter. So it makes a semicircle, and we know semicircles are 180 degrees. All right, so it means from here to here is, boom, 180 degrees. So since this is 92, that means the portion we wanted to find, this portion right here, is 180 minus 92. So this would have to be 88 degrees. And like I said, x, the intercepted arc, is going to equal half the inscribed angle x is equal to half the intercepted arc. So x equals 44 degrees. Okay, that's it. Let's put a circle around it. All right. Similar stuff going here, where again, an inscribed angle. This right here is a central angle because the vertex of the angle is at the center of the circle. And the relationship here is, since they have the same intercepted arc, where the angles end at the same points, they have the same intercepted arc. That means, very similar, that the inscribed angle is half the central angle. That means we have to multiply the inscribed angle to equal the central angle. We're going to multiply it by 2. So you just take 2 times the inscribed angle, and then we can set it equal to the other side. I'll just clean this up a little bit, where we have 2x equals x plus 18. And from here, easy peasy, subtract x from both sides, and we get x equals 18. All right, fair enough. All right. So we need to find the value of x here. Again, we got to be able to differentiate between inscribed angles and central angles. This is a central angle. Oops, didn't mean to press that. All right, so how many degrees does a whole circle add up to? So this whole circle is 360 degrees. We only need this portion right here, so we need to find arc BC. So all we have to do is, well, 84 plus 140 plus the measure of arc BC. That's going to equal 360. Okay, so we're going to get 224 plus the measure of arc BC equals 360. Subtract 224 from both sides, and the measure of arc BC equals 136. All right, and then hopefully you can figure this out by now. If inscribed angles are half the arc measure, inscribed angles are half the central angle. Hopefully we realize that central angles equal the intercepted arc. So that means that x is the central angle. It's just going to equal 136, the intercepted arc. Cool. All right. Then we got this here, where we notice we have this pink angle here, which is 3x plus 7. And we got this blue angle right here, which is 6x minus 11. Notice how they have the same endpoints. So they have the same intercepted arc. All right, so that means when we have two inscribed angles share same arc, then they are equal. All right, so literally just 3x plus 7 equals 6x minus 11. Subtract 3x from both sides. 7 equals 3x minus 11. Add 11 to both sides. 18 equals 3x. Divide both sides by 3. And 6 equals x. Smiley face again. We haven't done a smiley face in a while. All right. And then last problem, just kind of a combination of some other problems that we knocked out. And it's going to be, okay, we need Q, P, S. We need to find the measure of this inscribed angle. All right, so how are we going to do that? Well, first we're going to find this right here, that arc. And then similar to before, we know the whole arc of a circle, the entire circle is 360 degrees. So I can say the measure of arc QR plus 126 plus 90 equals 360. So the measure of QR plus 216 equals 360. So the measure of arc QR equals 144 degrees. So that's 144 degrees. Okay, well I need this right here. It's an inscribed angle. It's half its intercepted arc. So we just divide by 2. So I can say the measure of angle QPS is equal to 144 divided by 2, also known as 72 degrees.